Welcome back, folks. In today's class, I'll be talking about the relative motion concepts, and we'll talk about the 2D relative motion. And this question is from the Pearson textbook. And the question says that you need to transport the three people across a airstrip, which is 350 kilometers due west in 2.25 hours. So this is where the plane should be at. That distance is 350 kilometers in west direction, and this distance should be traveled in 2.25 hours. So we can assume that the same amount of time, whatever is given to us, will be taken by the plane to cover the complete displacement. And I can find the speed or the velocity with which the plane is flying. That will be equal to distance or displacement divided by time. That will come out to be 350 divided by 2.25. So if I do the math, that number will come out to be 155.9. That's the number you're gonna get from here. Not exactly 9, it should be 6. 155.6 kilometers per hour in the west direction. Now, what else information is given to me? If the wind is blowing at 40 kilometers per hour at 65 degrees north of west. So wind is blowing in the north of west direction. So something like this. That's how the wind is blowing. How can I draw it? If I draw a navigation system, so this becomes north, this becomes the west direction. So this vector becomes north of west direction, and this is the destination point where the plane should be. And so I can call this one as VG. VG equal to 155.6 kilometers per hour, because that's what it says, that uh, you need to transport three people on an airstrip due west. Okay, so that's why I will call it as VG. And the plane then obviously should fly somewhere in this direction. That will be the plane's actual speed, so VA. Now I'm going to try and apply the rules which we've learned earlier for to check out the diagram. Is the tail of the VW diagram of VW is touching the tip of VA. Of course, I should have written this one as VA. So this is actual velocity VA. So that is happening. So tail of this is touching the tip of the VA. And then both VA and VG start from the same point. Again, they both are starting from the same point. So that condition is also satisfied. So it means our diagram is correct. Now, if I look into this diagram, this is not a right angle triangle, so I cannot apply the trig ratios. When I say the trig ratios, I mean I cannot apply sine theta, cosine theta, and tangent, but I can apply the sine law, or cosine law, cosine law. I can apply these things to this diagram. Okay, so if you understand how to apply the cosine law or sine law, go ahead and apply that and you'll get the direct answer. But I'm going to try and use the component method because that's what we've learned previously. So I'll try and solve this question using component method. To solve this question with the component method, I need to remember the formula which we've learned in the previous videos. So VA plus VG is equal to VW. That's the formula I will apply to the question. So first of all, I'll draw both the vectors on the navigation system separately. So this vector is 155.6 kilometers per hour. This is due west. So this is west direction. This is VG. And then another vector which is in the northwest direction. So this vector is somewhere in northwest direction. And this is 40. This one is 40 kilometers per hour at an angle of 65 degrees north of west direction. So I can easily, first of all, find the component of both the vectors. So this VGX value will be negative 155.6, or I can write it as 155.6 in west direction. And then VGY value will be 0 because there is nothing in the y direction for this vector. And then I will try and find the component of this vector, there will be a component in the upward direction and one in the west direction. So I can draw the west component down here also. That will be better. And this is in the north direction. So VWX is equal to 40 cos of 65 degrees. VWY is 40 sine of 65 degrees. So now I will try and do some calculations and try and find out these numbers. So this value comes out to be 16.9 kilometers per hour. Again, this is in west direction, so I'll keep this as negative. And this one is in north direction, so I'll keep this number as positive. So this value is 36.25 kilometers per hour. I got both the numbers from here. Now I will find the resultant value. So before I find the resultant, I have to find the VA plus VG is equal to not VA plus VW is equal to VG. So this formula I will apply in X direction and also in Y direction. So VAX value will come out to be VAX. VWX is how much? VWX is negative 16.9 and VGX is negative 155.6, negative 155.6. So if I were to do the math, this goes on the other side. VAX is equal to negative 155.6 plus 16.9. That's going to give you the number 138.7 kilometers per hour. All right. So if you're not going to use this formula, then your answer will be wrong if you end up just using VG and VW. So something like VG plus VW is equal to VA. If you end up doing this way, then your answer will be wrong. So remember, you need to use this down here. And now same formula I'm going to apply in the y-axis also. So VAY plus VWY is equal to VGY, and VAY is what we are looking for. VWY is, we've earlier figured out, that is 36.25 equal to VGY. There is no component of this vector in the y direction, so this is 0. So I'll place this down here as 0. So VAY value will be 36.25 but negative. So VAY is 36.25, 36, I should write it as 36.25 in south direction. Again, the units are kilometers per hour. Now I'm going to draw both of these vectors on the navigation system and then find the resultant value. So this is 138.7 kilometers per hour. So this is negative, so this will be down here, and this is south. Again, because it is south, so I will draw it down here, and the resultant will look something here. So I will replace this y component here on further left side. So this is 36.25, this is 138.7, this is the angle I'm looking for, and VA value will come out to be 138.7 square plus 36.25. Here I'm using the Pythagorean theorem. Again, some of you can ask the question that why I haven't used the negative. You can keep using the negative here also. It's not going to make any difference because I've drawn it on the navigation system. So that's, I need not to use the negative. Negative square will become positive. So eventually it's not going to make any difference. So if you solve this, negative 138.7 square plus negative 36.25 square, and that's going to give you the final resultant value. VA comes out to be 143 approximately kilometers per hour. And I can find out the angle theta also. So that is tangent theta equal to opposite upon adjacent. In this case, Opposite is 36.25. Again, if you want to use the negatives, you can. If you don't want to use the negatives, it's up to you. Answer's not going to change because why? Because I've drawn it on the navigation system. Tangent 36.25 divided by 143, and the angle will come out to be approximately, it is 15 degrees. And how I'm going to mention the angle? This angle is moving from west towards the south direction. So south of west. So final answer will be VA value is 143 kilometers per hour at an angle of 15 degrees south of west. So if I go to the very first diagram which we've drawn for this question, if I draw the navigation system down here also, I can see this is in south of west direction at an angle of 15 degrees, comes out to be 143. So again, if you want to solve it using the cosine law, go ahead and try and do that. If you don't know what is cosine law, you can use it, the component method. Hopefully you understood how to solve the problems, use 2D problems on the relative velocity, and I'll see you with another video. Till then, goodbye.